All right, good morning, everybody. Welcome back to Calculus 2. I've got my teaching assistant, Doogie Mowser, here. Say hello, Doogie. He just had breakfast, but he's waiting for more breakfast because that's the kind of cat he is. We are going to integrate x cubed over x squared plus 2x plus 1. Now, I know that this is obviously a factored form of x plus 1 squared. We're going to leave it as is for now because we want to use partial fractions on this because there isn't any u du kind of combination I can make out of this. So I'm kind of stuck. I'm like, I gotta do some kind of surgery on this first. Um, but since the top degree is bigger than the bottom degree, my first job is to do everybody's favorite thing in the world, polynomial division. Okay. The reason I say that is because I taught intermediate algebra for a very, very long time. When we got to this point, everybody who was taking that class was so overjoyed to get to this section. They loved doing long division. Okay. So we're going to go ahead and we're going to say, how many times does x squared go into x cubed? It goes in x times, of course. We have to go through our division operators. So we have x squared times x is x cubed. 2x times x is going to be plus 2x squared. And then 1 times x, of course, is x. And then we're going to subtract, right? And figure out the next version of what we're going to do. X cubed minus x cubed is 0. 0 minus 2x squared is going to be negative 2x squared. And 0 minus x is going to be minus x. Now, we've got this. We're not done with the division yet because x squared go into negative 2x squared? It sure can, negative 2 times. So we're going to say, okay, this is going to be negative 2x squared. Again, just multiplying these pieces together. So 2 times 2 is going to be negative 4x. And then 1 minus 2 is going to be minus 2. And again, we're going to subtract. We're subtracting a negative. I'm taking away your debt. Okay? So negative 2x squared minus a negative, that's 0. Negative x minus a negative 4x, we're adding 4x. 4x minus 3x, we get 3x. And then 0 minus a negative 2, we get 2. Now the question is, can x squared go into 3x? It cannot. So we're stuck with, okay, we decided we're not going to do it anymore. So it cannot. So we're done with the division there, except for this is a remainder. Okay, now unlike in fourth grade of systematic agony, you don't write down R with this thing. We've done it right like in a grown-up way to say my answer is going to be x minus 2 plus 3x plus 2 over x squared plus 2x plus 1. Now, we could try to figure out, like, is there some kind of a fancy thing we could do to kind of hammer this into a UDU combination? And we might be able to, but it's going to be kind of tough. We're going to add x's, and it's going to be a tough thing to deal with. So now we're ready to say it's ready for partial fractions. Okay. Now I'm going to take this x squared plus 2x plus 1 and like note that it's a factored form. So we're going to say partial fraction decomposition, and we're going to say we have 3x plus 2 divided by x plus 1 squared, and say that this must be equal to x plus 1 plus b over x plus 1 squared, remembering all the little rules that we had for partial fractions. Okay. And now we have to go ahead and sort this out. I'm going to go ahead and do this one the long way because it's not too bad. I'm going to go ahead and multiply both sides of my equation by x plus 1 squared. What that's going to do is that's going to give, I'm going to swap the order as well. So we have one of my x plus 1s canceled, one of them didn't. Okay. Plus b, both of my x plus 1 squareds canceled on this one. And this is equal to 3x plus 2. So going through and equating coefficients, we have ax plus a plus b must be 3x plus 2. Equating coefficients, as far as my x coefficient, take all the things that have a on the left-hand side, equate them to all the things with x on the right-hand side. Oh, a is 3. Well, that was a tough system. So here we have a plus b is equal to 2. Since I know that a is 3, we have 3 plus b is equal to 2. B must be negative 1. Okay, so my problem that I started off with here, I did a couple of different surgeries on this thing. We're going to say that this original integral here, x cubed over, okay, so we have the integral of x cubed over x plus 2x squared plus 1 dx is equal to, what was my original problem here? This is going to be, well, we were up here, x minus 2. Okay, the integral of x minus 2. And then we have to go ahead and go back to our a and our b. A was equal to 3, so we're going to say this is, oh no, it isn't. Yeah, it is. A is equal to 3. So we have 3 over plus 3 over x plus 1. Okay, and b was negative 1, so we have minus 1 over x plus 1 squared. Now, we could go ahead and find a u du kind of a combination for this one, but since u is going to be x plus 1, du is just going to be dx. So we have 3 over u minus, I think you can do this one in your head. Okay, I'm going to try it. So my integration here, we have 1 half x squared minus 2x, just integrating this little piece here, plus 3 times the natural log of x plus 1. Put it in the absolute values because I have no idea what x is. And if x is, we start x is negative 2, then we're going to need absolute values. And then we're going to integrate this u to the negative 2, add 1 to it. So we're going to get negative 1 over negative 1 plus we have 1 over x plus 1 because it's still going to be to the negative 1 power. Don't answer yet. Now it's plus c. Okay, so this is going to be our problem here. This one's easy enough. You could take the derivative of this. And did I get back what I should have gotten back? And you will get exactly back what you're supposed to get back here. Okay, so that's how you do this kind of a problem. This one had a few steps in it, but none of them were that terrible. So I'm glad that this problem worked out so nicely. Hopefully you'll get to see this one in your exam. But thank you very much for watching the video, and I'll see you in the next one. Take care.